Internal energy is energy that's stored by the atoms and molecules that make up a system. It includes the total potential energy and the kinetic energy of all the particles. Kinetic energy increases when we heat a substance up and its temperature increases, but it doesn't increase while a substance is changing state, like when it's melting or boiling. Potential energy increases when the substance melts or boils. It doesn't change when the temperature is increasing, only when the substance is changing state. This graph is called a heating curve. It shows us how the temperature of a solid substance changes as more energy is added by heating it. At first, the substance is a solid, but as it's heated, it will reach its melting point and turn into a liquid. Notice that while the substance melts, there's a flat line, which tells us that its temperature isn't changing. The liquid then heats up until it reaches its boiling point and turns into a gas. Again, while it's boiling, the temperature doesn't change. We know that the substance's kinetic energy increases when its temperature increases. So anywhere on the graph that the temperature is increasing, the substance must be gaining kinetic energy. When a substance is changing state, its temperature doesn't change, which explains why there's flat sections when the substance is melting and boiling. In these times, the substance is still gaining energy, but its kinetic energy and therefore its temperature are not increasing. That's because it's now gaining potential energy instead. At all points on the graph, the substance is gaining internal energy because it's always gaining either kinetic or potential energy while it's being heated. Remember that internal energy is the total potential energy and kinetic energy. As long as one of those is increasing, internal energy must be increasing too. We can also draw a cooling curve for the same substance, starting as a gas and cooling down. Where the temperature is decreasing, kinetic energy is decreasing. On the flat sections, where the substance is condensing and freezing, potential energy is decreasing. At all points, the substance is losing internal energy because it's always losing either kinetic or potential energy as it cools down. Here are some practice questions for you to try. Pause the video and give them a go. The internal energy of a substance is the total kinetic and potential energy of all the particles, and they could be atoms or molecules. The internal energy of a substance changes when it's either changing temperature or changing state. The substance is gaining kinetic energy when the temperature is increasing, and it's gaining potential energy when it's changing state, which is the flat sections. It's gaining internal energy at all points on the graph because there's always either kinetic or potential energy increasing.